Hi folks, I'm Florian from iProcess, and today we talk about continuous integration in automotive as part of our software and system engineering basics series. This is going to be an entry-level overview for those out there who are new to the topic. Continuous integration as a term was first introduced by Grady Booch in his publication The Booch Method in 1991. The main motivation is to find issues as early as possible. The method is based on the concept of sharing a common repository for all software code written by developers in a project and by having a defined continuous integration and build schedule for this shared repository. The method itself does not dictate the schedule or frequency. Common options include the time-based schedule, leading for example to a daily or weekly integration and build, or the commit-based schedule to perform integration and build every X commits, where X can be as small as 1. Continuous integration relies on the following principles. The code repository has to be in place so the software code is available to all involved parties. It is under version and configuration management, and it is protected from loss. This code repository requires a sufficient branching structure and management. Automated build systems are a core feature empowering continuous integration. The system is configured to run integration, build, and automated code checks on a designated schedule based on a team's strategy. The system used for performing the continuous integration, build, and code checks is capable to trigger following actions such as component hill and system test execution in an automated environment. So while all of the above is not new, as mentioned, it has been part of software development world for 30 years. It is fairly new to the automotive world, and the automotive world is struggling to get it implemented. Why is that? In general, it is worthwhile to state the following. Put in efforts to get to CI where it makes sense. If your project only sees a single code commit per week or so, CI is probably not adding much value. The same with regards to receivers of the CI. If your validation team needs 4 weeks to run a regression test, it does not help to integrate hourly. True the other direction as well. By the way, there is no benefit in speeding up your testing from weeks to hours if the development does not provide new packages to test more than once a month. It is important to see the big picture and improve at a coherent pace to get the value of CI. Going back to the automotive industry challenges, does that mean everybody has to go agile to implement CI? No, it does not, but it sure helps. The automotive development is still very waterfall oriented. Work products are specified, designed, implemented, tested, and then integrated into bigger systems, and the cycle starts over. Continuous integration can technically work with the waterfall model, just it would likely need to make those cycles iterative and speed them up. And here are 3 important insights about a working CI system the automotive industry has to adapt to. First, to be successful, software needs to have a backbone architecture. That means it always works. Some features might not work, but the base software is able to run on the target every time it comes out of the CI system. Second, accept the fact that features will fail the test in the early stages. This is normal and expected, and it will improve over time. But what you want to achieve is, third, test the integration of new features against regressions in the full system. If your new feature is creating an issue on an interface, you want to know that as soon as possible. It can be extremely cumbersome and time-consuming to fix issues late in the feature development process. Summary. Build often, test early, fail early, fix early. Be ready to release at any time. iProcess can help you to design, review, and improve your toolchain and pipeline, and to put the continuous into your integration.